From here. All right. Yeah. Well, thanks again, Justin, for the very nice introduction, and good to see that map got me back to my graduate student life. I was well paid to do digitizing of a bunch of paper maps, but really fast forward here, I'm delighted to have this opportunity to discuss with you the frontiers of CyberGIS and geospatial data science. I was showing off my mug earlier. Happy GIS Day, folks. You could see looking at your Zoom. And let me dive directly into my small slide deck. And the motivation for this discussion really is tackling a variety of scientific and related societal challenges are dependent on the convergence of different paradigms of scientific practice, including, for instance, data-driven analysis. And that's what GIS has been really focusing on, and theory-based modeling and simulation. You know, of course, the research computing community has made great contributions to that, and observational work, you know, field work. And these paradigms are converging, and the convergence is increasingly dependent on geospatial data and software capabilities. By geospatial, I mean geographic and spatial, right? Having such components in your data, and such data is widely around us, including even your personal phones. Whether you notice or not, your location information is gathered, for instance, through your mobile devices. And in 2021, the National Science Foundation, through its one of the 10 big idea initiatives called Harnessing the Data Revolution, funded 5 institutes, and one of which is called iGuide, stands for Institute for Geospatial Understanding through an Integrated Discovery Environment, involving these collaborating institutions on this slide, and it's headquartered at, yeah, you see the URL, there's the project website. If you click that, iGuide.io, you'll get to our project website, and definitely quite a bit of information on the website. Our vision is digital discovery and innovation through harnessing the geospatial data revolution. And the mission is to transform convergence and geospatial sciences for holistic sustainability solutions. And to realize our mission and vision, this diagram summarizes the key components of the Institute. We're pursuing a collection of convergence science catalysts enabled by cutting-edge geospatial, artificial intelligence, and data science approaches, supported by core cyber infrastructure capabilities and services. We're also conducting a variety of education and the workforce development programs and activities, engage diverse partners. We regularly evaluate what we do and pursue knowledge transfer opportunities with the different stakeholders. And how do we bring all these components together, right? Well, requires a collection of disciplines. And this is a summary of the disciplines involved in the Institute. And there are 3 key approaches for us to achieve this integration, namely map, connect, and discover. And I'll elaborate each one of these 3. But the central hypothesis here is looking at, for instance, this collection of sustainability challenges in United Nations terminology, sustainable development goals. Let's say if you look into the challenges of food security, inevitably you would run into concerns of water security. And oftentimes food and water security challenges are associated with biodiversity challenge. And of course, all of these challenges are in the broader context of climate change. So you need to have holistic views and approaches to addressing these challenges. And a major argument here is geospatial is serving that holistic integration for addressing these challenges in an interconnected fashion. So first, map. And this is where GIS has been developed for over multiple decades, right? You pull spatial data and you examine patterns. But GIS has not been developed well for is to understand the processes driving the changes of the patterns. So how patterns and processes are interacting is really a frontier in the dimension of mapping. And positively speaking, in the past several years, the development, for instance, digital twins in different domains allows us to link the patterns and processes together, right? Understanding the dynamics, which is, I think, quite exciting. And this requires integration of high performance computing with big data to knowledge transformation and high fidelity visualization, visual analytics, and also collaborative approaches, right? Virtual organization is a term in the cyber infrastructure community. So if you look at this integration, which is really the core of CyberGIS, it's departing from the conventional GIS, right? Largely based on integrating layers of maps, and also oftentimes the data could be just residing on your personal computers. And this integration requires moving away from those conventional frames. And that requires the development and innovation of cyber infrastructure. And this development has been really active in the past few years. There's a special issue on the PNS organized by Don Wright, who is now the chief scientist at Esri. At that time, we were scratching the surface to see how the emergence of cyber infrastructure with a spatial focus has really empowered scientific knowledge production in not only natural and social sciences and even humanities. And fast forward, looking at the problems as I was summarizing from the motivation slide, you really need to have the different domains coming together to look at a challenge like this, which we just briefly refer to as the aging dams infrastructure challenge. In the US, we have around 92,000 dams, and quick message here is over 6% of such dams are falling behind maintenance. Now, you might have been tuned to multiple very horrible failures in the past decade or so. And especially with climate change, we now are facing uncertain risks of such failures. And the failures are not constrained to local communities, but also could be cascading impacts beyond local and regional levels. So how do we get a solid grasp of such risks? So the idea of a scalable geospatial data science approach has been developed, linking these different perspectives together. Well, number one, if any dams might fail, you would first be exposed to floods, most likely. And in the general context of geospatial science advances, increasingly we're getting to this cross-scale linkages from very fine scale at the local level to, let's say, in this case, continental scale processes and patterns. And a major frontier here is to be able to link them holistically. And for this example, mapping flood inundation in the United States, methodology is called height above nearest drainage hand. Intuitively is very simple. You have digital elevation models and you have river streams. If you could determine the water level along the river streams, and you know the topography between your location and the river streams, you'll be able to derive the water flow for your location, therefore determine the potential inundation. And if you do this at a local level, that might not be terribly challenging, but if you do this at the continental scale, now you have the data, like the national elevation data. Now, the more advanced version of that is the three-dimensional elevation program by the US Geological Survey. And then, of course, you have the catchment and flow lines, national hydrography data, the water gauges along the rivers, and then you combine them based on the idea I was explaining. You really need advanced computing resources to achieve this scalable computation. So the computer we developed called Roger, standing for Resourcing Open Geospatial Education and Research. And it's also named after Roger Tomlin, who was credited as among the first created GIS in the world. And David Mainman really is a leading scholar in the intersection between hydrology and the GIS. And when this work was developed as a collaboration, made some progress, quoting him here, combination of detailed GIS representation of stream network and supercomputing to determine the flow is transformative. And CyberGIS has delivered a major success for the nation. So again, this multi-scale representation from the local level to a continental level and done through advanced computing was an exciting step. An important outcome of that collaborative work is this workflow, which you are able to access through the CyberGIS X platform. The link is at the top of this slide. If you go to that platform and with the academic institutions, your credentials, you should be able to quickly register and access such a workflow. The basic idea is making this reproducible, and you'll be able to execute this workflow. We developed through multi-years of large team collaboration. And then this provides a basis for advancing this methodology and the related work, and is also enabling computation data intensive work to be shared with the broader community. Built on top of this work, if you look at potential failures of dams, then, as I mentioned, it's not just limited to local, right, impacts, but could be regional and beyond. And you would assess the cause and effects and agents involved, associated, and the flows of materials. And one of the examples of such major failures, if you Google, you would see in South Carolina, I think 2015 in October, there was a major failure of multiple dams. You would get a sense of the impacts from that disaster. So, so how do you put all the perspectives together, right? And look at the risks and associated impacts of such failures? Well, you essentially look at, for instance, the physical processes that might be approached through modeling and coming from different domains. You need data, on the human side and the water side, land side, and you need to bring them together and then have the synthesis happening across multiple geospatial scales. And then you need to compute this. So it needs to be translated to cyber infrastructure resources, and especially for large scale analysis. So collectively, we term this as a geospatial knowledge hypercube, and especially for assessing impacts of potential agent dam feeders, you also need to look at unconventional data from text, and including news articles, literature, and compared to conventional geospatial data, text data is not straightforward to harness because it's potentially noisy and could be collected for different purposes than the ones we intended to use such data for. But the idea of the hypercube is to put a structure against such data. In this simple example, looking at the impacts in different dimensions, such as human economy, ecosystem, and the location of the dams, and of course, the temporal axis. And you have such a structure allows you to do more efficient, effective downstream information retrieval and analysis. So I'm sure you are all well tuned about large language models, and BERT is a lightweight model in that context. And of course, GPT is a more sophisticated in comparison to BERT. We started this work before ChatGPT became a thing. So the idea here is to sift through massive text data and extract related information to dams and the potential feeders and the impacts. So there's a prototype. If you go to this URL, you'll get to online application like this. It's right now serving the purpose of demonstration, so it's not connected to real world application. But the idea here is if you look at individual sources of text data, and then through this hypercube approach, you would be able to classify them, and then further to be able to extract locational and temporal components and simultaneously contextualize them into online maps. And then this will help this interactive linkage between the text data and the geospatial data, and then facilitate downstream analysis. So that gets me to the second approach, which is referred to as Connect. For iGuide, for CyberGIS and geospatial data science, we are working very hard to connect different types of data with the common geospatial representations and communities' domain knowledge. As I referred to, we have over a dozen disciplines involved and the learning resources. I'll talk about that later. And also working with the partners. And a key element of our Connect approach is the iGuide platform. This represents, I think, effort related to your interests, especially in the context of cyber infrastructure. And this recent paper really explains our longer-term vision in this regard. But the need for the iGuide platform is summarized by this illustration. You have a variety of data repositories, and you have domain-specific cyber infrastructure capabilities. But the kind of problems we're tackling cut across all of this. The agent dams example I showed you requires the interoperability and the linkage across the data repositories and associated domain-specific cyber infrastructure capabilities. But we want to simplify the access to such resources and capabilities in a way the actors from a variety of domains could focus on their scientific questions and workflows, as opposed to dealing with the nitty-gritty details of sorting out interoperability and linkages across the diverse capabilities and resources. So that's really a key gap in our existing cyber infrastructure ecosystem. That's what iGuide platform is focusing on to address and fill the gap. So the platform is online. We've had a production release recently. The platform includes, at the moment, a suite of Jupyter notebooks and also a data catalog, which I'll explain later, and additional resources focused on education and access to distributed cyber infrastructure capabilities. So just a very simple illustration showing you, this is an online platform from the left side, has a Jupyter notebook interface through middleware connecting the domain-specific cyber infrastructure capabilities here focused on geospatial, and going to the high-performance computing resources and the backend storage. But the 3 columns on the right are not supposed to be what scientists and users need to deal with directly. And it's encapsulated as modules, and components could be streamlined to support reproducible computation data intensive workflows. So we're partnering with Open Geospatial Consortium to standardize such modules and components so that these capabilities could be broadly adopted by the diverse communities related to the geospatial collaborations and geospatial cyber infrastructure. So the testbed 19 is a specific mechanism for coming up with the initial considerations for a potential standard, which we currently term as high performance geospatial computing, HPGC, includes multiple working components. And we also are running virtual consulting office, seem to be similar to your community's doing here. This is on average happening bi-weekly, with the selected topics could be coming from the iGuide community or beyond, to discuss how do we generalize such capabilities that iGuide has been advancing to serve the broader interests of diverse research and education communities. So for instance, if you have a topic you want iGuide to address, we'll be happy to hear from you with regard to your suggestions. And the past virtual consulting offices, the recordings are online, and you can see some of these examples there. So the final approach is to discover, that involves the production of new scientific knowledge, and what are the mechanisms for preparing the next generation to conduct such scientific knowledge production. And geoethics in the context of geospatial data science is a very important topic, considering the rapid development, for instance, AI. It's super critical now. We pay close attention to the ethical dimensions of our data science practice. So we are advancing scientific knowledge discovery through digital approaches. The Jupyter notebooks, the data repositories, we hope to link them and make them available to the broader scientific community, and then also achieve reproducible transactions and workflows, and enable ultimately convergence research. And this is a framework for a curriculum focused on geospatial data science. The effort is led by Eric Schutt at the University of Minnesota, again, using geoethics as example, which is the intersection between ethics and geospatial at the foundational knowledge threads. And then, of course, at this foundational level, you have computational thinking and data, method, tools, and cyber infrastructure. And you go up from this foundational level, you accomplish the connections, the intersections. And then you move up to specific knowledge frames, and geospatial AI and geospatial data science are concrete examples of that. And ultimately, this helps bring diverse convergence teams together to tackle complex problems, like I mentioned earlier in my talk. And there are just increasing many such challenging problems, right? As I was alluded to at the beginning. So again, specifically on geoethics, how would you work against bias coming from the data collection or processing or transformation? And how would you address privacy coming from geospatial data? And how would you address misuse of technologies? So all of these matters are central to now our scientific discovery processes. So there's an explicit team in iGuide focused on this and coming up with concrete guidance for the broader community to work with geospatial data-based scientific collaborations and discovery. So we had a forum, which is the first of its kind, conducted earlier this fall, and the link at the bottom would get you to the webpage of this event, and we're committed to do this in the next several years in an annual frequency. So stay tuned with us, and that's just a few pictures. With the link at the top, you will be able to get to the recordings of our plenary sessions. We have released a few recently, and there will be more available on this website. And excitingly, I think there's a cohort of the younger generation emerging to tackle the kind of challenges I'm sharing with you, but also embracing the associated opportunities. To summarize, what I have shared with you today is really this holistic approach, what I consider to be in the middle of a revolution, really enabled by what you do, advanced computing, cyber infrastructure at the bottom here from the illustration. And then this is the very big moving trend of digital transformation, enabling the innovation of geospatial science and technologies. CyberGIS example of that. And really from the top, we see a variety of scientific challenges and associated societal problems that cannot be resolved by any single disciplines or domains. We need to bring these domains together. And that requires critical spatial thinking and innovation of data science focused on spatial computational theories and the methods. But importantly is this vertical integration and the synthesis across these different knowledge domains brings us the power for potential solutions to a variety of scientific challenges and associated societal problems. And of course, sustainability is such example from many of the associated related challenges. And it takes a village to pursue this roadmap. This is an article published on the magazine of what is called Geospatial Directions, I think is the name of the magazine. But the article here is written in lay terms explaining what iGuide does. And of course, the group picture here showing our team members. I'm telling you what we do here, but really credits goes to amazing team we have coming from the institutions, but also the partners we have. This is the initial set of partners, and we're interested to grow the community of our partners and to tackle the kind of challenges I'm sharing with you requires broad partnerships coming from industry, government agencies, and other kinds of organizations, even here, including, for instance, museums. So with that, I want to thank you for your attention. Again, I appreciate the opportunity of this sharing, and I'll leave you with 3 bubbles: map, discover, and connect. Happy to take any questions.
Thank you. So yeah, if there's any questions that folks have on in the audience, if you'd like to turn on your microphone, that's fine.
Comments, clarifications, feedback, advice, all welcome.
Yes, looks like we have one.
Hi, I'm Moitali Mitra. Thank you very much for that presentation. It was concise and very easy to digest. One question, I'm in the healthcare field at Weill Cornell, and I was at Johns Hopkins before. So with healthcare data, what is your experience about some use cases?
Yeah, great question. And as you know, GIS and more broadly spatial analysis has a very strong synergies and intersections with healthcare analysis, broadly speaking, public and the population health, right? So personally, I, for instance, got involved recently in the pandemic, analyzing the geographical differences to healthcare access. Because we understood during the pandemic and even beyond, there's this incredible disparity in terms of different communities and populations accessing healthcare resources, exacerbated by COVID. So that's, I think, a recent example I'm personally involved. And to, again, pursue a study like this, especially you look at very fine scale details, but at the same time examine large scope, because a lot of times policies are made at large scale, right? State and national, but the challenges are often getting felt by the local communities. So how could you connect these different scales? Just like analogy to what I presented, this flood and the impacts, you get the local level dynamics, but the same time, it's a regional national issue. But I see similar trend is happening in different communities and in different scientific research contexts, is the ability to be able to bridge these different scales. And of course, with the availability of diverse sources of geospatial data, we're getting more equipped. But sometimes we're still challenged by having access to adequate data. And healthcare, public health is an example because of potential data privacy issues for the broader research community to be able to share and access the data needed for not only research purposes, but also for public policy support. So that's, I think, still an evolving challenge. I think the research communities are getting kind of the collaboration needed to tackle that challenge. And the research community actually is an important community in that context, because at the end of the day, data needs to live somewhere, right, for making the access reasonable and broadly approachable. So I hope I said enough to maybe give you a little sense of what could be the possibilities, and of course there are associated challenges and opportunities.
Yes, thank you.
Looks like we have a question from Carl. Carl, do you want to go ahead? And it looks like you had 2 questions piling up in there. Go ahead.
Yeah, this is coming from Chad. At the bottom, can you compare contrast cyber infrastructure needs of processing GIS data versus that of medical imaging? Yeah, I think there are commonalities and differences. I happen to actually get my career started in the research computing community. And when I started my career, I was actually working on medical imaging problems. So this is a question I have some personal experience with. And I think from, these are all spatial data in a sense. So there are some common technical nature of such data and associated tools. But of course, the basic infrastructure might be similar for data management storage needs. But as you go above those layers from the technical side, you will likely run into more domain-specific needs and requirements, especially from the application side. So that will get sort of divert into different knowledge areas and associated tools. So that would be my general reaction to this question. So I think the basic infrastructure could be leveraged, but more closer to the applications and users. We would need to address the needs more explicitly and customized to the applications and end users. And I will say one more thing. Giving a talk to this group made me reflect back on my early days of career development. I hope I had this community when I was starting my career. So I'm jealous you are getting so well organized. I think this is a really great idea of self-organization, and definitely I see potential, and maybe you have already realized significant benefits of organizing yourselves, and is a very important, incredible community from my own experience.
Great, thank you. Other questions? That makes sense to me that you had your experience was in the HPC space or in that compute space earlier on. I was drawn to that diagram that you had where you were showing the compute with Jupyter notebooks and explaining the workflows and the processes there. Yeah, it would be great if you could share your slides. We would make that open to the public, or make that open to the group for folks to see those slides, if you could share those.
Yeah.
But yeah, that was something that I was drawn to, and there was, this idea, or there was a GeoEDF, which was the extendable geospatial framework. So can you talk more about what that is all about?
Yeah, that is a capability developed by a group from Purdue, and the leader of the effort is Carol Song. Actually, she's in the research computing and high performance computing community. The work itself is focused on streamlining and simplifying data connection and transformation from especially online data repositories. So let's say if you get a piece of interesting data from, let's say, a NASA data repository or USGS data repository, and then if individually as a scientific user, I want to download that data and get that data rightly configured and processed, it's actually not an easy task.
Right.
So this capability is focused on getting that simplified and streamlined and become a common service. And within iGuide, and Carlson actually is a co-PI of iGuide. We're integrating that into the iGuide platform so that this would be a much more easily, readily available service for the purpose of connecting different infrastructure, cyber infrastructure communities and capabilities.
Great. And I did post a link to more information on that when I was listening to your talk, and I put that in the notes if others are interested.
Mhm. Yeah, so if you would be doing the kind of data downloading, processing, massaging, well, I think for a lot of folks, perhaps in this call and in the research computing community, you would write scripts, right? You know, you would perhaps do a cron job because it could take a while. Now, how do we get rid of this bottleneck? Because basically, there are not a whole lot of people like us could be doing this regularly, right? And also, there's a potentially scalability challenge. Even if you have the skills of writing scripts to do this, you might not have the infrastructure to accommodate such data transformations. So that's what GeoEDF is focusing on.
We are coming up on the close of the hour. So are there any other questions? We have time for one more if folks have one. Great. Yes, thank you so much. Thank you so much for being here today and laying out this very interesting program, and appreciate your time very much.
Well, thank you all, and it's my pleasure. And I would wrap up the conversation by telling you there's one image or logo representing the UGA geography participant. I think that wins the competition today of Zoom representation.
Great. There it is.
All right, happy GIS Day, and
Great.
have a round for your community work.
Thank you.
Thank you. Thank you, everybody, for attending today.
Thanks, Justin.